Over your review, number 12. This is for our factoring test and also our solving quadratics test. And we're going to solve the quadratics by factoring, with some graphing, and with the quadratic formula. Okay, so here we go. This first problem is already factored for us because I see something times something, and I know that those are factors when they're getting multiplied together. And if the two things multiply to give me 0, then either the first thing, 5x plus 3, equals 0, or the second thing in parentheses, 7x plus 1, equals 0. So as long as your problem is already factored, then we're ready to set up our two equations. And it's just the first factor set equal to 0, and it's the second factor set equal to 0. And then I just solve those two equations. And this is what you would get. As long as this isn't a real-world application type problem, then I'm going to leave my answers in fraction form because that's the most accurate answer I can give. Okay, number 2. This one is not factored. You can see how it looks different than number 1. So I need to try to factor it. So I have to make sure that it does say equals 0, which it does, so I'm good there. Then I look to see if it has a GCF. It doesn't. So then, because there's 3 terms, I'm going to do my A times C rooftop. And this is what I end up with. What multiplies to be negative 24 that adds to be 5? It's a positive 8 and a negative 3. And then once I get it factored, I set my first factor, x plus 8, equal to 0, and get negative 8. And then I take my second factor, x minus 3, set that equal to 0, and get positive 3. Okay, number 3. This one is not factored. So first I look to make sure that it's set equal to 0, and it is. Next thing I look for, do I have a GCF? And I do. So this is what it looks like after I pull the GCF out. And then I take my first factor, 7x, and I set it equal to 0. And then I take my second factor, x minus 4, and set it equal to 0. And then I just solve those two equations. So if I solve my first equation there, I get 0, and when I solve the second equation, I get 4. Okay, number 4. This one is not factored either, and I need to make sure that it does say equals 0 because it does not. Since my y squared, since my quadratic term is positive over here, I'm going to move both of these. So to move a minus 3y, I would add 3y to both sides. And then that would become a 0. Shoop. To move a positive 35, I would subtract 35 from both sides. And then that would become 0. Shoop. And then the left-hand side, I just have to put that in order. So I start it with the highest exponent to the lowest. So 2y squared plus 3y minus 35 equals 0. Once it's set equal to 0, I'm ready to start my factoring. So first I look to see if I have a GCF, and I don't. And then I see that I've got 3 terms, so I do A times C rooftop. It is the long one, and this is what it looks like. 10 and negative 7 are the numbers we want. And once I get the problem factored, I set my factors equal to 0. So I set y plus 5 equal to 0, and I get negative 5. And then I set 2y minus 7 equal to 0, and I get a positive 7/5. Okay. In the next section, we're going to solve these problems with the quadratic formula. And I'm just going to go ahead and show you number 5. It was set equal to 0, so I was good to go. I identified my A, my B, and my C. And then I plug everything in like the formula tells me to do. Because I can't take the square root of 57 and get something pretty, I did go ahead and use my calculator to give me decimal answers. Okay, just to run through the quadratic formula real quick, let's sing it. X equals the opposite of b, plus or minus square root b squared minus 4ac all over 2a. So that's our quadratic formula, and I just do exactly what it tells me. These parentheses right here are very important, so make sure that you always have parentheses around this b before you square it. Okay, next one. This one does not say equals 0, so I have to make that happen. Hang on just 1 second. I'm just going to show it to you. Here it is. This one. I haven't been doing much. Hey, can I come down there like towards the end of class because I'm trying to make a video? I'm so sorry. Okay, all right, bye. Sorry about that. Okay, so I moved my minus x squared by adding x squared to both sides. That became a 0. And then a is 1, because that's the number in front of the x squared, b is a 2, and c is a 7. And then if you ever get a negative under the square root, then we get no real roots. There are imaginary solutions, but we learn about that later. Okay, let's flip. Okay, number 7. This is another quadratic formula problem. I need to make sure that one side does say equals 0, and it does. So my a is a 6, my b is a negative 13, and my c is a 6. And then I just plug everything in. On this one, I end up with the square root of 25, which comes out nice and pretty to be a pretty little 5. And then I can get myself 2 exact answers. The first one I got was 3/2, which if you gave me 1.5 or 1 1/2, that's fine. And my other answer reduces to 2/3. Like I said, I really like fraction answers as long as it's not some real life application, or if I'm graphing it, I'd probably want a decimal if I was graphing. But since it's just calculate it, give me the answer, then simplified fractions are really the best kind of answers. Okay, we have another quadratic formula. This one does not say equals 0. And I decided that I was going to go ahead and make my x squared positive. That's just something I kind of get into a habit of doing. You don't have to do that, but I'm going to make my x squared positive, so I added 2x squared to both sides. And then now that's a 0, and my other side now says 2x squared plus 4x minus 3. I just wrote the 0 on the right side instead of the left. And then I can see that my a is a 2, my b is a 4, and my c is a negative 3. And then I work it out. And this is what I get. You cannot take the square root of 40 and get anything nice and pretty. So I put it in my calculator, and I got 2 decimal equivalent answers, rounding to the nearest tenth. Okay, number 9. It gives us this equation. It talks about h is height and t is time. When they tell me something about 3 seconds, I know that that means my time is 3. So I put 3 into that T, and I plug 3 into that T, and I just work it out. And that gives me 15 meters. Okay, next one. I want to know after how many seconds will the ball be 15 meters high? Well, that happens to be the height. So where the H is, I put the 15. And then I don't like my quadratic term to be negative, so I moved both of these, which gave me this right here. And then I decided I was going to solve this by factoring. So first I pulled out the GCF, and then I A times C roof-topped the rest, and then I worked on solving it. But you could have solved this by the quadratic formula, and you could have solved it by graphing if you had your graphing calculator. You could graph it and see where it touches the x-axis. This one actually came out nice and pretty, so that would have worked out pretty nice. But I checked to see if it factored, and it did factor, so that's how I went about it. And then once I have my factors, the 5, that will never be a 0, so I just ignore that. And then t minus 3 is 0 when t is 3, and t minus 1 is 0 when t is 1. So the answer is 3 seconds and 1 second. That's how high the ball, or that's how long it takes for the ball to be 15 meters high. Okay, on this next one, I did try factoring it. It wants to know if the ball is 25 meters high, so that's how high the ball is. So I put 25 into the H, and then I moved this whole side so my quadratic term could be positive. And then because it wants to know what T is, I did try factoring. I pulled out my GCF, and then I tried to factor what was remaining with A times C rooftop, but there were no numbers that multiplied to be 5 that add to be negative 4. So I ended up doing the quadratic formula. And when I end up with that negative under the square root, I know that there's no real roots, which means that the ball will never get this high. Okay, and this next one, it wants to know when will the ball hit the ground. Well, the ball will hit the ground when the height is 0. So I put 0 where the H is. I went ahead and I moved this whole side, which gave me this, and then I did go ahead and factor this. So first I pulled out the GCF, and then after I pulled out my GCF, I was left with t minus 4, and then I set my first factor, 5t equal to 0, and I set my second factor, t minus 4 equal to 0, and I solved. T equals 4 is the only answer I want. That's when the ball hits the ground. This is where the ball starts. At 0 seconds, that's where the ball starts. And at 4 seconds, it has come back down and has hit the ground. Okay, I'm going to stop the video here for right now, and then I will end up making another video over the rest of the review. So I'm going to stop here right now, and I will send you another video and put another video on Blackboard to go over the remainder of the review. Thank you.